Right now we have a working prototype. It tracks the sun fine, but we're constantly trying to improve this to make it more robust and streamlined. Today I'll be talking to you about the improvements we've made and how we track the angles of our panels so we can orient them to the calculated position of the sun. As I mentioned, this involved using a magnetic rotary encoder, and here's one here. It's this little chip that has a field sensor right there, and it also comes with this little round magnet. And the magnet goes up against, there's the magnet. The magnet goes up against that field sensor, and as it rotates, it can detect the change in the angle of rotation, and that's how you know what direction your panel's facing. But of course, all that needs to be mounted and made waterproof, which is what you're here to see. Up until now, I've been using a 3D printed enclosure that I designed. I've actually spent a lot of time on this and kind of proud of it, but you can see that here it can be mounted to our aluminum framing. There's a cable gland that it comes in here through here that's waterproof, and it's got a waterproof top on here. I have an opened up version over here, and looking on the inside you can see a 3D printed strain relief here. Here's what it looks like on the outside, and that just holds on to the cable so that somebody can't like rip it out. And then it connects to our magnetic rotary encoder here. That's going to slide down and be held in place with a couple of screws against a little thinned out window, and that's a little bit thinner so it can detect the magnetic field a little bit more easily. And then the magnet's going to be held in place by this cap that goes on the end of our shaft, and that goes right up against here, and as it turns it'll be able to detect the angle of rotation. And as for the seal on the top, I've got a little gasket that I've 3D printed with TPU, and that's a special kind of filament that's a bit more rubbery and provides a better, more like cushiony seal, and that goes on the top, and then a cap goes on top of there, and it's screwed down. The rest of the plastic is made with PETG filament, and that is better at heat resistance than like your typical PLA. And so two different types of filament. Here it is on our panel frame and connected to our custom built controller box. The angle readout is connected to the north-south axis. And when I turn the rod, the readings adjust the angle. All of my pride aside though, I mean, this is pretty complicated. It's got 4 printed parts with 2 types of plastic, lots of washers, screws, and nuts, connector here, a cable gland, just a lot of things going into this, a lot of print time, and also a lot of places where things could go wrong. You could have water coming in through where the cable gland is, through the top. This window's only a couple layers thick, so that could get punctured. And so a lot of failure points, and it really takes a long time to assemble, like getting this chip in there just right and covering it all up. It's kind of a pain. So great job on a short-term solution, like yay, but I really need to make something simpler and smaller. Like look how big this is versus how big the chip is. We can make this a lot smaller. So that's what I'm going to show you next. So you've probably used heat shrink before. You just put this on wires that have been soldered together, and then you can either apply a heat gun or the side of your soldering iron to it. It shrinks up and protects those connections from touching each other, and makes them a little bit more sturdy. But maybe what you didn't know is they make this heat shrink stuff big, like really big. Big enough that you can definitely fit the chip inside here. And also inside they make it that it has adhesive inside of it. So when you heat it, this adhesive melts and it seals all of your connections in a waterproof way. First, take your chip, you solder all your connections to it, make sure that's working the way you want it to. Cut this to size, and then put your chip in here, apply some heat, and it'll shrink up around there and waterproof it with that adhesive. So much faster and easier to make. And also like just it's so small. Like compared to this, now we have this size thing instead. I mean just really a huge size reduction. And now the key test is, will this actually work? Can the magnet still be detected through here? Something to help with this, as it was cooling, I was pressing down to kind of push the glue off of the field sensor there. That helps not just to like get the magnet as close as you possibly can to here, but it gives you a little dimple that you can see. So when you're aligning the magnet to it later, it's a lot easier to see exactly where the field sensor is and to line those up. Here we have it set up. It's held in place with just some washers and T-nuts. Again, I have it connected to the north-south axis. Ignore the east-west axis. It's kind of going nuts because I don't have anything connected to it. And yeah, the angles are adjusting as we turn it, so it works. It also needs to be waterproof, so let's try that out. Okay, here I have a bowl of real water. You should be able to see the north-south axis there. Again, ignore the east-west one. It's going crazy. And yeah, so I'm going to put our waterproofed magnetic rotary encoder in the water and see that it works. And just kidding, that's a joke. And so I put this in here. Seems to still be working, and if I can align it right, it's working. Yeah, so cool. Our waterproof magnetic rotary encoder. Honestly, I didn't try this with the old enclosure. I wasn't confident enough to do it. Of course, this won't work for something like a light or humidity sensor, but for something like a temperature or an accelerometer, it should work really well. Something I'll have to keep a lookout for is in the summertime, is the heat going to be so much that it'll melt the glue? But if so, I'll just have to try to find a brand with maybe a higher melting temperature, or just keep it shaded. All right, I hope this helps with whatever you're working on. I'd love to hear about it along with any other suggestions you have for us. Good luck on your projects. I'm sure mistakes will be made. That's okay, just fail fast and keep moving forward. Until next time, bye.